Welcome. This project is designed to engage K through 12 students in the foundational principles of solar energy. We are emphasizing strategies for improving its efficiency through hands-on learning and accessible demonstrations. To support this goal, we are introducing a solar tracking panel system, a practical example of innovation in action. By showcasing this technology, we aim to cultivate curiosity and critical thinking in younger audiences, empowering them to explore sustainable solutions with confidence and creativity.
Ho, ho, ho. I'm so glad I'm making toys for all the children right now with my solar panel. Oh no, ho, ho, ho. I've lost all my power because I don't have a solar panel that moves towards the light. What will I do, ho, ho, ho?
Boss, what will we do? We can't make toys for the children now because we have no power.
So what is the problem? Currently, solar panels are often viewed as too expensive and not offering enough return on investment. And our design has a little more expensive upfront cost, as there are more components to it than just a solar panel, like the servo and the light sensors. But it has a way better return on investment than normal solar panels, as it keeps collecting energy the entire time the sun is out, rather than only collecting energy for a fraction of the time when the sun is out. Solar energy is a very promising technology which has potential for further growth and expansion if it were more affordable for more people, and it takes the pressure off other non-renewable sources.
Here at Magic Labs, this right here, what you're seeing here, was our first vision for our design, right? We were gonna make this all out of Legos to really appeal to the children, but way too expensive. So what we decided, this was actually going to be out of wood, and then we're going to keep this little Lego house to still appeal to that children, but also reducing the cost. You guys know how expensive Legos are. What are you going to do?
So what we have here is a very special solar panel we developed that is a lot better than a stationary solar panel because it's able to rotate to follow the light. So what we have here is we have two sensors, one on each side of the solar panel. And this Arduino microcontroller down here compares the light value from the two sensors and decides what would be the optimal angle for the solar panel in order to capture the most light so that we can get the most energy from it. So now a little bit about how we built this. We started with this wooden base, and then we glued these two beams onto the sides to support the solar panel. And then attached to the beam, we have this servo motor that rotates the solar panel through this metal rod, which is attached right here. And then it's attached underneath the panel with these things, which is glued on to make it strong. And then all the circuitry is mounted right here and underneath. The circuitry is mounted up here so we get a good angle of light for the light sensors. And then the Lego house, we just built that and put it in front with these wires running to this light so that you can see when the light comes on. So now we have the lights dimmed and it's time for the demonstration. I'm going to show you how once we introduce a light into the equation, it's going to follow it. So we're going to take this, I'm going to do that, move it over to this side. It's going to follow the light over to this side and capture more energy than if it was just straight up and down, for example. And then we'll move it over here to simulate the movement of the sun throughout the day. And obviously it'd be a lot slower than this, but you get the idea. The solar panel is rotating. This sensor is seeing more light, so it's turning to this side. Now, of course, the solar panel is powering something. What's it powering? The little light in the house over here. So we're gonna start in the morning. It's gonna go over here. We're gonna move, and throughout the day, it's gonna track the light and keep it on throughout the day. Whereas if it was just straight up and down facing one direction, you'd lose light through one part of the day.
All right, so our design clearly meets the 5 through 18 age range because every single kid loves Legos. And it has to be within an overall budget of $150 and an outside material budget of under $50. We were able to get the whole thing under $36. It has the benefits to society. Our design promotes the use of renewable energy, and it also improves renewable energy. Our design demonstrates electrical engineering through the wiring, and it demonstrates mechanical engineering through the servo motor, and it also demonstrates environmental engineering because we are working through renewable energy. And that's included an Arduino microcontroller, which is right here.
For $36, you can own this beautiful solar panel. It's lightweight, portable, and allows for easy access for everybody, including people outdoors. Unlike this $800 solar panel here that is only single use and can't be placed anywhere else, you can place these solar panels everywhere that you're staying, allowing for more energy over time to be used in comparison to just this solar panel there.
Now that it is all over, this project all started from just a simple idea for a large problem, and now our team has made it become a reality. As you were shown, our design ultimately succeeded in its goals. It showcased an incredible simple design for a cheap cost, highlighting that solar energy can be utilized and we will not need a giant panel and spend an absorbent amount of money. Furthering this project, we plan to incorporate better materials like a metal that will ensure it will not be damaged outdoors, as well as hooking up a light source so we don't have to rely on our phones. We would also include a battery that showcases the amount of energy stored over time. And lastly, on behalf of All Magic, I would like to thank you all for sitting through this video.